when did you call the local minimum value of the function? The c is called the local minimum value of the function. The two required numbers are x is equal to 12 and y is equal to 12. If you add 12 plus 12 is 24 the sum. If you multiply, the product is 144, which is the maximum value. And what is given? X plus y, sum of two numbers is 60, therefore x is equal to 60 minus y. And let us consider this as p. Let p is equal to xy cube. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty of mathematics, Vidhyaashram PU College, the temple of excellence. In my previous class, we have discussed regarding the approximation, finding the approximate value using differential. Now in this session, I am going to discuss regarding very important concept that is called the maxima and minima. How to find the maximum value and the minimum value of a function. So how to find the local maxima, local minima? There are two methods. One is by first derivative method, another one is by second derivative method. That we will discuss. Now let us, before going to the exact problem, let us know what is maximum and minimum value of a function. Now suppose if a continuous function goes on, increases and decreases again, it will reaches a point. This is called, this is generally a maximum value, and this is called the minimum value of a function y is equal to f of x. Now how to calculate the maxima and minima? Now in general, the concept of derivatives are used to calculate the maximum and minimum value of various functions. The concept of derivatives are used to find the maximum and the minimum value of a function. So here we are using the concept of first derivative as well as the second derivative. That is why we are going to call it as first derivative test and second derivative test. Now let f be a function defined on an interval I. F is said to have the maximum value in the interval I if there exists a point C in I such that if f of c is greater than f of x, if f of c is greater than f of x for all x belongs to the interval I, then the function is said to be maximum. So if it is greater, f of c is greater than f of x, then the function is said to be maximum for all x belongs to I. Then the number f of c is called the maximum value of f in the interval. The value f of c, if x is replaced by c, then you are going to get the value. That value is called as the maximum value of f in I. That is a function defined on an interval I. Then f is said to have a maximum value in the interval I if there exists a point C in I such that if f of c is greater than f of x, then f of c is called the maximum value of f in that interval. Similarly, a function f is said to have a minimum value in the same interval I if there exists a point C in I such that f of c is less than f of x. If f of c is greater than f of x, then you will have a maximum value. If f of c is less than f of c for all x belongs to I, then the number f of c is called the minimum value of the function. So if f of c is greater than f of x, then we will have a maximum value. If f of c is less than f of x, then the function will have a minimum value, and the minimum and maximum value is got by putting c in given equation. Now, so therefore, let us come to the definition. What is the definition? Let f be a real valued function and c is an interior point in the domain of f, then c is called a point of local maxima if there exists an h which is greater than 0 such that if f of c is greater than f of x for all x in c minus h comma c plus h in the interval by c minus h and c plus h. The value f of c is called the local maximum of the function. Similarly, when did you call the local minimum value of the function? The c is called the local minimum value of the function if there is an h greater than 0 such that f of c is less than f of x. F of c is less than f of x for all x in the interval my c minus h comma c plus h. then the value of c is called the local minimum value of the function. Local minima and the local maximum value of a function. Now, let us come to the problem. Find all the points of local maxima and local minima of the function given by f of x is equal to x cube minus 3x plus 3. Now, let us represent f of x is equal to x cube minus 3x plus 3 as equation number 1. Now, differentiating with respect to x, f dash of x is equal to 3x square minus 3. Now, for the function to be maxima or minima, for the function to be maximum or minimum, f dash of x is equal to 0. That is, what is f dash of x? That is 3x square minus 3 is equal to 0. Now, just solve this and get the critical points. So, f dash of x is equal to 0 since 3x square minus 3 is equal to 0. Now, just you can remove the common factor. 3 is the common factor out. What we are going to get? X square minus 1 is equal to 0. This is nothing but x plus 1 into x minus 1. So, therefore, x is equal to plus 1. X plus 1 is equal to 0 means x is equal to minus 1. And another value is x minus 1 is equal to 0 in the sense x is equal to 1. So, therefore, x is equal to minus 1 and x is equal to plus 1 are the critical values. Here, this is nothing but a and b. Now, consider first point when x is equal to minus 1. When x is equal to minus 1, now on solving f dash x is equal to 0, we are going to get, so x is equal to minus 1 and x is equal to plus 1 are only the critical values, critical points. Now, just apply first derivative test to check whether at x is equal to minus 1 and x is equal to plus 1, the function is either maximum or minimum and find out the values. Now, let me take the first value. When x is equal to minus 1. When x is equal to minus 1, f dash of x, when x is equal to minus 1, if x is replaced by minus 1, then this what we are going to get. So, at x is equal to minus 1, f dash of x is less than 0. This is negative. So, if f dash of x is less than 0, this implies less than 0. Therefore, the function is less than means it is maximum at x is equal to minus 1. So, therefore, the function is maximum, local maximum at x is equal to minus 1. Now, the maximum value is got by putting x is equal to minus 1 in equation number 1. So, you will get f maximum is equal to, substitute the value, this is minus 1 whole cube, minus 3 into minus 1 plus 3, this is minus 1 plus 3 plus 3, this is nothing but 6 minus 1 is 5. So, therefore, at x is equal to minus 1 and the maximum value is 5. Maximum value is 5 is the maximum value. This is called the first derivative test. Now, let us come to the next problem. Now, this is very important problem for 3 marks. Very important problem for the point of examination. Very simple. Find two numbers whose sum is 24 and whose product is large as possible. Very important. So, what is required to find is to find the two numbers. Let us find two numbers whose sum is 24. If you add two numbers, the sum is 24. If you multiply them, product is maximum you have to get. Now, let us consider, let x and y be the two numbers. Let us consider the two numbers as x and y. Let x and y be the two numbers. X and y are the two numbers. Now, what is given? The sum given, x plus y is equal to 24. Okay? Find the two numbers whose sum is 24 and whose product is as large as possible. X plus y is equal to 24. So, suppose if one number is x, then the other number will be y. So, therefore, we can write if x is one number, then the other number y is equal to 24 minus x. Now, what is given? Whose product, let us call it as the product. Let A is equal to X into Y. The product is large as possible. Now substitute A is equal to X into what is Y? 24 minus X. Therefore, A is equal to 24X minus X square. Let us represent this as equation number 1. That's it. Differentiate, you will get the answer. That is, just form the equation, differentiate it and find the maximum and minimum value. That's it. So, let us consider the two numbers. Let X and Y be the two numbers. Given the sum of two numbers is equal to 24. Suppose if X is one number, then the other number will be 24 minus X. Why? So, what is given the product? Let us consider the product A. If A is equal to product of two numbers, X and Y. So, A is equal to X into Y is 24 minus X. A is equal to 24X minus X square. Now, differentiate this. Differentiating with respect to X. What you will get? dA by dx is equal to 24 into differentiation of x is 1 minus differentiation of x square is 2x. Differentiate this again. Differentiating again with respect to x. With respect to x. What you will get? D square a by dx square is equal to 24 0 minus 2 into x is 1. This is minus 2. Here itself you can say, since d square y by dx squared negative, second derivative is negative, means the function is maximum. Therefore, f is maximum. As we know, for the function to be max, yes, for the function to be maxima or minima, to be maximum or minimum, f dash of x is equal to 0. What is that? That is, what is f dash of x? This. dA by dx is equal to 0. dA by dx is equal to 0. That is nothing but 24 minus 2x is equal to 0. Therefore, 2x is equal to 24. X is equal to 24 by 2. That is equal to 2. When x is equal to 2, f dash of x, that is nothing but dA by dx is equal to 0 and f double dash x, that is nothing but d square a by dx square. D square a by dx square is always, that is given, it is negative. Negative in the sense, therefore the function is maximum. Therefore, the function is maximum at x is equal to 12. Now substitute this value, put x is equal to 12 in equation number 1, that is x plus y is equal to 24. So you will get y is equal to 24 minus x, 24 minus 12 is equal to 12. So therefore the two numbers are x is equal to 12 and y is equal to 12. So therefore the two required numbers are x is equal to 12 and y is equal to 12. If we add 12 plus 12 is 24 the sum. If we multiply, the product is 144, which is the maximum value. Followed? This is how we are going to find. Very easy and very important problem. So by differentiating, we will get dA by dx is 24 minus 2x and d square a by dx square is equal to 2 into 1 is minus 2. Now let us come to the next page. For the function to be maximum or minimum, what is the condition? dA by dx is equal to 0. That is, f dash of x is equal to 0. What is dA by dx? 24 minus 2x. 24 minus 2x is equal to 0, which implies 2x is equal to 24. X is equal to 24 by 2 is 12. X is equal to 12. Now, at x is equal to 12, dA by dx is equal to 0. That is, f dash of x is equal to 0. What about second derivative? d square a by dx square. d square a by dx square, it is already negative. This is minus, negative. F double dash x is less than 0 means, therefore the function is maximum. Therefore the function is maximum at x is equal to 12. Now, therefore the function is maximum at x is equal to 12. The function is maximum at x is equal to 12. So, now to find the maximum value, Now, put x is equal to 12 in the given equation. Therefore, one value of x is equal to 12, therefore, x is equal to 12, the other value is y is equal to 24 minus x, that is 24 minus 12, that is equal to 12. So, therefore, the two values are x is equal to 12 and y is equal to 12. So, if you add, the sum of two numbers is 24, and if you multiply, the product is 144, which is as large as possible. So, when x is equal to 12, therefore, the function is maximum at x is equal to 12, and the maximum value is got by putting x is equal to 12 in equation number 1, that is y is equal to 24 minus x. Therefore, y is equal to 12. If one number is equal to 12, then the other number is also equal to 12. Therefore, the two numbers are 12 and 12. Okay. Now, let us come to the problem. Next problem is, find two positive numbers x and y such that x plus y is equal to 60 and xy cube is maximum. What is maximum here? X into y cube. X into y cube is maximum. What is given? Given sum of two numbers x plus y is equal to 60 and xy, let us call it as this, let p is equal to x into y cube. Let us represent this as equation number 2 and this is equation number 1. Now get the value of x from this. What is x? This implies x is equal to 60 minus y. Substitute here, put x is equal to 60 minus y. Then this becomes p is equal to y cube as it is, and x is nothing but 60 minus y. Simplify this, 60 y cube minus y to the power of 4. That is, p is equal to 60 times y cube minus y to the power of 4. Now differentiate this. Differentiating with respect to y. What you will get? dp into dy is equal to 60 into 3y square minus, this is 4y cube. This is nothing but 6 3s are 18, 180 y square minus 4y cube. Differentiate this again. d square p by dy square is equal to 180 into 2y minus 4 into 3y square. This is equal to 360 y minus 12y square. This is second derivative. Okay. Now, given, what is given? X plus y, sum of two numbers is 60, therefore x is equal to 60 minus y, and let us consider this as p. Let p is equal to xy cube. Substitute the value of x is equal to 60 minus y from 1, y cube into 60 minus y, 60 y cube minus y to the power of 4. Differentiate this, dp by dy is equal to 180 y square minus 4y cube. d square p by dy square is equal to 360y minus 12y square. Now, you know, for the function to be maxima or minima, dy by dx is equal, that is f dash of x is equal to 0. This is dp by dy is equal to 0. For the function to be maxima or minima, for function to be maximum or minimum, what is the condition? dp by dy is equal to 0. That is, what is dp by dy? 180y square minus 4y cube. 180y square minus 4y cube is equal to 0. Simplify this. 4y cube is equal to 180y square. If I transfer this side, so what happens? So here, this one y square gets cancelled. 4y is equal to 180, or y is equal to 180 divided by 4 is nothing but 45. So y is equal to 45. Now when y is equal to 45, dp by dy is equal to 0. What happens to d square p by dy square? So if you substitute 45 here, 360 into 45, 360 into 45 minus 12 into 45 square, 12 into 45 square. On simplifying, this is equal to, I will get the simplified answer, 1,600 minus 12 into 24300. 24300. This is equal to 1,600 This is 16200 minus 24300. On simplifying, what is this equal to? Minus 8100. This is negative, less than 0. Therefore, the function is maximum. Therefore, the function is maximum at y is equal to 45. Okay, by second derivative test. Now, one number is 45. Therefore, the other number is, substitute here. What is the value of x? X is equal to 60 minus y. That is, x is equal to 60 minus 45. X is equal to 15. So, therefore, the two numbers are x is equal to 15 and y is equal to 45. See, if you add, you will get it as 60. The sum is 60. The sum of two numbers is 60. X is 15. Y is 45. And the product xy, x 15 into 45 whole cube is maximum you will get. Okay. So, the required answer is, therefore, the two numbers are 15 and 45, where the sum is x plus y is equal to 60. Okay. This is how we are going to find the maximum minimum value as well as the two numbers depending upon the given condition. Hope you followed this. This type of problems are very, very important. Usually you will get this type of problems for the point of examination. So that's regarding today's class. Let us discuss a few more problems in maxima and minima in the next session. Thank you very much. Thank you.